Hi everyone, my name is Doris Gutierrez-Rosales. I am a PhD candidate at Stony Brook University. Today I will be presenting the Silo, Half-Gigapixel Cylindrical Stereoscopic Immersive Display. The Silo is a cylindrical immersive visualization environment for advanced data exploration and collaboration. To achieve this, we focus on four key aspects: ultra-high resolution display to enhance details and immersive visual analytics, co-located collaboration to allow multiple users to interact in the same space, optimal pixel density to prevent pixelation ensuring clarity, and stereoscopic rendering to enhance depth perception for accurate 3D views. The silo consists of 168 tile high-resolution displays arranged in 21 columns, delivering over half a gigapixel of visual detail. With a 4.8 meter diameter and 2.4 meters height, it comfortably accommodates 6 to 7 users, ensuring both clarity and immersive collaboration. Rendering and synchronization are handled by a visualization cluster of 6 interconnected nodes. 5 nodes each drive 32 display panels, 4 columns each, while a 6th node coordinates rendering. Each node is equipped with 8 NVIDIA RTX 6000, which means each one has 48 GB of VRAM, which ensure real-time performance. They also have 2 NVIDIA QuadroSync boards that keeps the visual carefully aligned across the entire display surface. Custom-designed aluminum mount frame supports the system, while a noise-canceling cabinet encloses the node servers, minimizing operational sound and maintaining an optimal immersive experience. Beyond immersion, this setup enhances data visualization, supporting applications that demand a broad field of view and exceptional detail, enabling more precise analysis and decision-making. Silo applications. We present applications developed for the silo. Flooding simulation, submerged. We adapted the immersive flooding visualization submerged for the silo stereo cylindrical display. Firefighters and emergency managers use it to collaborate and plan evacuation procedures. The silo stereoscopic depth perception improved analysis of flooding height and alarm distances. Biomedical visualizations. The silo immersive high-resolution display helps scientists explore molecular structures and analyze biomedical datasets, enhancing clarity and aiding in structural bioinformatics research. Architectural models. The silo was used for immersive architectural visualization, allowing stakeholders to improve and assess a new campus building. Visualizing missing information. The projection on the silo occurs only on the walls, so to compensate for the missing ceiling and floor, we use conformal mapping and optimal transport mapping. We assume a hypothetical capsule to project the surface onto the original silo structure, as presented in Figure A. This approach preserves angles and shapes while allowing for area distortions. Refer to Figure B for this. The transformation is computed using the rigid curvature flow method, ensuring a smooth and accurate mapping onto the curved display. While conformal mapping preserves angles, it introduces area distortion, particularly at the missing ceiling and floor. To correct this, we apply optimal transform mapping, which preserves areas at the cost of angles by combining conformal and optimal transform mapping. With this, we achieve a balanced transformation that maintains spatial accuracy while ensuring uniform projection onto the silo. While Figure A presents the conformal mapping projection, Figure B presents our approach, conformal mapping plus optimal transport. To evaluate the effectiveness of this approach, we analyze the log ratio of corner angles and triangle areas before and after mapping. The histogram of corner angles, Figure A, shows a strong concentration around 0, confirming that angles remain locally consistent with minimal distortion. Meanwhile, the histogram of triangle areas, Figure B, exhibits a sharp peak around 1, indicating that optimal transport mapping successfully maintained relative area proportion despite minor global scaling. These results validate that our combined mapping approach provides an accurate and well-balanced transformation for visualization on the silo curve display. To further assess the benefits of our mapping approach, we conducted a virtual colonoscopy study with 4 medical experts analyzing a case with a polyp, which is an abnormal tissue growth. With the standard projection, participants took about 6 minutes longer to locate the polyp compared to our conformal plus optimal transport projection. Experts also noted reduced cognitive and visual fatigue, reinforcing its effectiveness for medical visualization in an immersive environment. In Figure A, we can see a medical doctor performing a virtual colonoscopy in the silo, while Figure B presents our mapping, which reveals the polyp that was otherwise hidden in the floor of the silo. The green region highlights the recovered information using our technique. To further evaluate silo capacities, we conducted a user study comparing 3 immersive environments: flat, which was the powerwall measuring 19 by 11 feet, curve, which was the silo environment in monoscopic setup, and silo, which was the silo environment in a stereoscopic setup. The study followed a within-subject design where 19 participants, 7 women and 12 men, aged 18 to 35, completed 4 different tasks. The first task was meant for the user to get used to each environment. T2 or task 2 was a depth comparison task between points on a scatter plot. On the other hand, T3 or task 3 was a pathfinding and navigation task. Using a controller, the user navigates through the scene following different cues until they reach a final destination. T4 or task 4 was an object identification task where the user were asked to identify differences between 2 different proteins datasets. We conducted both quantitative and qualitative analysis to evaluate the effectiveness of the silo. For the quantitative result, we found that silo had a statistically significant effect on completion percentages, particularly in T2 and T3. The ANOVA confirmed this difference, and post-hoc Turkish tests showed that silo outperformed both curve and flat across tasks. For the qualitative results, we used the NASA TLX to assess workload perceptions. These results demonstrate the silo's ability to reduce workload while enhancing performance, making it the most effective environment for immersive tasks. As part of our user study, we gathered qualitative feedback from participants about their experience in the silo. Many highlighted the benefits of the immersive stereo environment, particularly in terms of spatial awareness, depth perception, and comfort. Our findings highlight the strengths and challenges of large immersive visualization facilities. First, we demonstrate the silo's effectiveness in balancing speed, accuracy, and workload for demanding tasks. Second, we acknowledge the importance of system optimization. Improving software, drivers, and tool support is crucial for usability and reducing setup complexity. Lastly, our future work aims to develop new human-computer interaction methods for stereocylindrical displays and explore off-axis stereo rendering for multi-user interactions. Thank you.